Hello everyone, myself Rahul. Welcome to my presentation on embedded system software. In this video, we will be discussing what is an embedded system software, and a simple assembly language program. As you can see on the screen, the majority of electronic gadgets which we use in our day-to-day life is based on embedded systems, from our smartphones to our smart TVs, home appliances, and even our cars. Let us start with what is an embedded system. An embedded system is a specialized computer system designed to perform dedicated functions or tasks within large systems. Software is essential for controlling, managing, and enabling specific functions in embedded devices. The four major software components are initialization code, operating system, device drivers, applications. Initialization code prepares the system for operating during startup. Operating system, it manages hardware resources and provides services for software applications. Device drivers is the software component that enables communication between hardware devices and operating system. Applications are the software programs which perform specific tasks to end users. Initialization code refers to the set of instructions executed during system startup to prepare the hardware and software operation. Phases of initialization code are: the initialization code typically consists of phases such as hardware setup, memory configuration, peripheral initialization, and system parameter initialization. The operating system in an embedded system plays a vital role. It manages hardware resources, provides services and facilitates communication between software components for efficient operation. Now let us learn the applications of embedded system and ARM processors. The operating system schedules dedicated applications that handle specific tasks in an embedded system. Applications perform processing tasks while the OS controls the environment. Embedded systems can run one or multiple applications simultaneously. ARM processors are widely used in networking, automotive, mobile devices, etc. ARM processors and high performance applications. ARM processors are widely used for their high performance applications and due to their efficient architecture, power optimization, and scalability. Let's get started with our first program in Keil Microvision. Now we'll learn a simple assembly language program that multiplies two numbers. Now open Keil Microvision software. To write our first program, we need to create a new project. Go to project, new Microvision project. Now let us create a folder on desktop. Our project name will be first project. We are writing code for LPC2148 microcontroller, which is a high performance 32-bit RISC based microcontroller. Click on no, this folder is not required. Now to write the code, we need to create a new text file. Before starting with the assembly language program, let us learn few basics of assembly language program. The first line in assembly language is written as area name, area type, and area attributes. Area keyword is used to allocate memory for new section. In our program, we are using multiply as the section name. So area keyword is used to allocate memory for new section called multiply. Area type defines whether it is a code, data, or constant. And area attribute defines whether it is a read-only file or a read and writable file. And next line is followed with entry keyword. This keyword designates the entry point of the program. And the next line is followed by start. The code execution begins from the start keyword. Also, we use a keyword called MOV, which is used to transfer data between registers. And also, we use NOP keyword also, which stands for no operation. This is just used to delay, add some delay in the program. And end keyword defines the end of the program and execution stops there. Let me copy the code. As you can see, all the text is in black color right now. When we save it in .s format, the text color changes. Let us name it as multiply .s. .s is the save type for this file. Now you can see all the text is changed to blue color. That is, only the keywords are changed to blue color. And we are transferring 6400 value to the register 1 and 3200 to the register 2. And we are using R3 to store the value of product of these two values. Now to execute the code, we have to add the file to the target. To add file to the target, go to source group, right click, and add existing files to source group 1. And close. Now you can see multiply.s is added to source group 1. Before executing, we have to build the target. Right click on source group, then build target. Now you can see there are 0 errors and 0 comments. Also, you have to notice that there are indentations maintained. If I change the indentation of the first line, that is area, now if we build the target, you can see that there are 2 errors. In this language, it is also indentation specific. So we have to maintain indentation. Now when we build the program target, you can see there are no errors. To execute this code, now we need to go to debug, start the debug session. It will check whether there are any errors again. Now the debug is completed. To run this code, go to debug again, then run. After a few seconds, you can stop the program. Now the values are changed here. In the register R1, it is stored as 1900 and register R2 C800. In register 3, 13,88,000 is stored as the value. Since you may notice that the values are hexadecimal values. Suppose we have given 6400 as the value and hexadecimal equivalent is 1900 for that. You can see here hexadecimal equivalent is 1900 and for 3200 hexadecimal equivalent is C80. You can say it is stored as E80. Now product of these two variables, that is 6400 into 3200 is 13,88,000. Now you can see in the register R3 it is stored as 13,88,000. Now you can stop the debug session and it exits back to the code. Hope you understood this. Thank you. I hope you found this video informative and enjoyed learning about our first program in Keil Microvision. Remember to like this video if you found it valuable, share it with others to spread the knowledge. Thank you.